Hi students, in today's session we are going to see the remaining problems of the exemplar questions from the chapter Aldehydes, Ketones and Carboxylic acids. Okay, so the multiple choice questions here, more than one options are correct. Okay, so which of the following compounds do not undergo aldol condensation? So what is the necessary criteria for aldol condensation, students? We need a carbonyl, preferably an aldehyde carbonyl. So this is the functional group. So the carbon that is directly attached to the functional group is known as alpha carbon, and this alpha carbon must possess alpha hydrogen. Okay, so this is the essential criteria, then only it can undergo aldol condensation. Okay, so here this is the functional group and this is the alpha carbon. It has hydrogen. Okay, so this will undergo aldol condensation. And see here, this is the functional group and this is the alpha carbon. See, if you watch, the carbon has 4 valencies already satisfied. It doesn't have any hydrogen, so it will not undergo aldol condensation. Okay, so this is a keto carbonyl. Okay, this is also an alpha carbon. This is also alpha carbon. So we have 6 alpha hydrogen. So this will undergo. But the question is which will not undergo, they are asking. Okay, so here this is the functional group and this is the alpha carbon. If you see, there is no hydrogen attached to it, so it will not undergo aldol condensation. So these two will not undergo aldol condensation. Treatment of compound, okay, phenyl benzoate with sodium hydroxide solution. See, I am going to write the mechanism, then you will know the product. Okay, when you treat with sodium hydroxide, what is the source? What it will provide? It will provide OH, hydroxyl ions, which are nucleophile. Okay, so this is a nucleophile. A nucleophile will always search for an electrophile. So if you see, where is an electrophile here? This carbon is attached to, you see, double bond O and another O. It means it is attached to 3 oxygen atoms, which is more electronegative. If you see, carbon, nitrogen, oxygen. Okay, when you move from left to right in a periodic table, the electronegativity increases. So oxygen has more electronegativity than carbon. So because of this carbon will have a partial positive charge. So this nucleophile will come and attack this carbon. Okay, so what is going to happen here? There is a pi bond. Okay, easily it can be polarized. Okay, so the carbon has to stick to its 4 valency, so the polarization of the double bonds takes place. Okay, so when it comes back, okay, the polarization, the pi bond cloud can be easily polarized, and it is an electromeric effect. Sometimes it will be on oxygen, and most of the time it will be on oxygen, and it will revert back to carbon. When it comes back, the weakest bond has to go out. Which is the weakest bond here? So already we have formed this one. Okay, OH here. Okay, the newly attacked. So this one will go out. Okay, when this goes out, phenyl O minus plus, so PH C double bond OH. You see, both in the presence of sodium hydroxide. See, your sodium hydroxide is a strong base. Okay, so these two will be present as a sodium salt. Okay, this phenol will also be present as a sodium salt, and this one will also be present as the sodium salt. So the answer is sodium phenoxide and sodium benzoate. Okay, so still sodium hydroxide, in the medium of sodium hydroxide we will be getting only the salts. Which of the following conversions can be carried out by Clementine reduction? What is Clementine reduction, students? If you treat a carbonyl, okay, if you treat a carbonyl, be it any group here, provided hydrogen, any group here. Okay, so what is the reagent for Clementine reduction? Zinc amalgam and HCl. This C double bond O will convert to CH2 group. Okay, so instead of double bond O, you will be having CH and CH. Okay, so I have written all the options here. If you see, the benzaldehyde to benzyl alcohol, no, it is no such transformation, so it is not. Okay, benzoyl chloride to benzaldehyde, no, it is not. See here, the cyclohexanone is converted into cyclohexane. Yes, instead of double bond O, we have 2 hydrogen. So this can be carried out. And here also, you see, instead of double bond O, we have this one. Okay, so the answer is the second and the fourth option. So, through which of the following reactions number of carbon atoms can be increased in the chain? Grignard reaction, Cannizzaro reaction, Aldol condensation, and Hell-Volhard-Zielinski reaction. See, by using Grignard reagent to any carbonyl, if you attack with any carbonyl, this is a nucleophile here, this will go. So at last what happens, we are attaching one carbon to the carbonyl, so we are increasing the carbon atoms. So this is an option. So for Cannizzaro reaction, I have taken benzaldehyde as an example. What will happen? We are not increasing any carbon atoms. One is getting reduced. One molecule will get reduced and one molecule will get oxidized. So are we increasing any carbon atoms? The carbon atoms remains the same in the product. Okay. So this is also not. Okay. Then Aldol condensation. Aldol condensation, you know, one molecule of aldehyde condense with another molecule of aldehyde. So obviously we are increasing the carbon atom. So this is the option. So what is Hell-Volhard-Zielinski reaction? When you treat any acid containing alpha hydrogens, okay, with red phosphorus and the corresponding halogen, your halogen gets substituted at the alpha carbon. So this is the reaction. Are we increasing any carbon atoms here? No. So what is the option? So Grignard reactions and Aldol condensation or the answers. Benzophenone can be obtained by, okay, so what is this reaction? This is Friedel-Crafts reaction. See, by seeing the reagent itself, you must be in a position to come to a conclusion that what naming reaction it is. Okay, so this is your benzoyl chloride in presence of AlCl3. Benzoylation takes place. So what is the product? Okay, in this benzene ring, this group is going to attach. Okay, so we are getting benzophenone, right? Okay, the another example, benzyl chloride, same benzoyl chloride reacts with dicadmium. Okay, so this is benzene twice cadmium. Okay, so this is an excellent reaction. So please learn it, students. So this is also an excellent reaction to prepare the benzophenone. Okay, benzoylation takes place. So these two are the examples. You may ask, the benzoyl chloride with phenyl magnesium chloride also gives benzophenone. But practically these two methods are not followed because they do not yield better results. Okay, so please know this. Okay, then your last question. So what is that? Which of the following is the correct representation for the intermediate of nucleophilic addition to the given carbonyl compound? You know that carbonyl compound is a planar compound. You see, a planar compound. When the nucleophile comes and attacks, so what happens? So the front side attack can also takes place as well as the back side attack. So it will be giving two. If it is going to give a chiral molecule, we can get two more. Racemic mixture. Okay, so what are they? So 1 and 2. Okay, so if it attacks from the front side, this will give you this isomer. If it is from the back side, it will give you this isomer. If it is going to give a chiral molecule. Okay, so since this is in planar, as you follow in SN1 mechanism, okay, the same explanation. Okay, hope this helped you a lot, and if you feel it worthy, please share with your friends. Thanks for watching.